Okay, so we are going to discuss about the balancing of redox reaction. So before this, we are already aware about the oxidation number concept. So oxidation number is very important before we start this balancing part. So about fractional oxidation number, the rules to assign oxidation number, how to identify oxidation, reduction, all these things we have already discussed. So I'll discuss the example from the synopsis itself. In the synopsis, we have the balancing using two methods. One is the oxidation number method and other is the half reaction method. So first, we are going to focus on the oxidation number method. As the name suggests, this method is based on oxidation number concept only. And mainly, the fundamental concept is using the oxidation number, we would balance the increase in oxidation number with the decrease in oxidation number. So there are set of rules which we are supposed to follow to get to the correct balanced redox reaction. So let's start with the first example over here, the problem number 7.8. We'll read the question first. Write the net ionic equation for the reaction of potassium dichromate 6. The Roman numeral indicates oxidation number with sodium sulfite Na2SO3 in an acid solution to give chromium 3 ion and the sulfate ion. So step number 1 is to convert the data given in words into an ionic reaction. Also, while writing the reaction, you should ignore the Kachra ions. Kachra ions meaning the spectator ions. Potassium, sodium, which do not undergo any change in oxidation state, are called the spectator ions. We are not supposed to include that because it will unnecessarily increase the work in the balancing. So, with respect to potassium dichromate, I would take only dichromate, which is Cr2O7 2 negative. Then sodium sulfite may I'll just take sulfite SO3 2 negative, giving chromium 3 plus ion, that is Cr3 plus, and sulfate ion SO4 2 negative. Now the medium of the reaction is acidic. It means that these reactions are carried out in an aqueous solution, meaning with the presence of water, of course, which is the universal polar solvent, and acidic solution indicates the presence of the H plus ions and the basic medium indicates the presence of the OH minus ions. So these are the two things which is important with respect to the question given. Now, step 1 is basically writing the ionic equation from the data given. Step number 2, we have to perform three things. I will call it as ABI step. ABI indicates A, assigning the oxidation number. B is to balance the atoms. And I is identify the species undergoing oxidation or reduction. Assign, balance, and identify. So let's write the equation again. Cr2O7 2 negative plus sulfite SO3 2 negative giving chromium 3 plus and sulfate SO4 2 negative. So assign indicates we have to assign the oxidation number mainly to the element which is undergoing a change. So with the observation, the chromium in the dichromate plus 6 is changing to 3 plus, and the sulfur in the sulfite plus 4 is changing to sulfur plus 6 and sulfate. So I've assigned the oxidation number to the elements undergoing the change. Balancing part may, we have to balance all the atom except hydrogen and oxygen. Why except hydrogen oxygen? Because with respect to water as the polar solvent, through the step, the hydrogen oxygen would get auto-balanced at the end of the reaction. So balancing here is mainly for the atoms undergoing the change. इसको balance करना है atoms undergoing the change. So 2 chromium will be balanced with 2 Cr on the right. Sulfur is already balanced because it is single atom on both the sides. Now identify. So plus 6 to plus 3 indicates the decrease in oxidation number. It's undergoing reduction. And sulfur plus 4 to plus 6 indicates it undergoes oxidation. So we have understood the redox part over here. So step 2 is basically the ABI rule, and you have to assign, balance, and identify. Step 3. In the step 3, we find how much is the increase in oxidation number. Now this increase is basically for the sulfur atom, and it is increasing from plus 4 to plus 6, which is an increase of 2 plus. And the plus 2 is the increase per atom. The increase is per atom. And the number of atoms in the case of sulfur is 1 only. Therefore, the total increase will also be same, meaning plus 2 into 1, that is plus 2. So this is the increase in the sulfur atom. Likewise, the decrease is happening for chromium. So the decrease in oxidation number for chromium is from the plus 6 to plus 3, that is minus 3. Again, this is the decrease per atom, but now the number of chromium atoms are 2. That is why the total decrease would be minus 3 times 2, which is equal to minus 6. Now, once you find the increase and the decrease in the step 3, which I call it as LCM step. So take the LCM of 2 and 6, which is 6. So we have to balance the increase and the decrease. So I will multiply the 2 wala part by 3 to make it plus 6, so that the plus 6 and the minus 6 becomes equal. And that is the core fundamental concept of balancing the redox. So the conclusion of step number 3 is to multiply the sulfur species by 3 on both the sides. Multiply sulfur species by 3 on both the sides. So after multiplying the sulfur species, I will just rewrite the equation. So I'll get Cr2O72 negative plus 3SO3 minus 2, giving twice of Cr3 plus and 3SO42 negative. And whatever is newly introduced, I will just highlight it so that it is clear. Then after the step number 3, the step 4 is balancing the charges. Step 4 is charge balancing. Now for the charge balancing, you have to identify the total charge on left and right and balance it using the H plus ion if the medium is acidic, or balance it via OH minus if the medium is basic. Meaning, if I talk about the charge on the left hand side, it is minus 2 and 3 into minus 2, that is minus 8. So write minus 8 on the left hand side. On the right, it is 2 into plus 3, that is 6 plus, and 3 into minus 2, that is 6 minus. So plus 6 and minus 6 becomes 0. So basically, I have a charge of minus 8 on the LHS and 0 on the RHS. Now the medium of the reaction mentioned was acidic. So I have to add the H plus ions. So on what side I need to add the plus so that my minus 8 becomes 0. So mathematically, minus 8 plus 8 would become equal to 0. So this plus 8 will be introduced by adding 8H plus on the left hand side. So in the step 4, we have to add 8H plus on left hand side to balance the charges. The charge balancing step will be the name of this step. We are balancing the charges. So my new equation becomes Cr2O7 2 negative plus 3 moles of SO3 2 minus along with 8H plus giving 2 Cr3 plus and 3 SO4 2 negative. So that is step 4, the charge balancing step. Now the step 5, which is the last step of balancing the redox, is oxygen balancing step. So we have to count the oxygen atoms on the left and on the right. So now again, if I do the calculation of oxygen atoms, so 7 in the dichromate, 3 threes are 9. That is 9 and 7, 16. 16 oxygen atoms on the left hand side. And on the right, I have 3 times 4 in the sulfate, that is 12. So basically, I need to again balance this. So 16 will be balanced with 12 by adding 4 on the right. So conclusion, you have to add 4 water molecules, which is equal to the oxygen atoms of water on the right hand side, RHS. And why we are doing this? To balance oxygen atoms. To balance oxygen atoms. So finally, my equation would be Cr2O7 2 negative plus 3SO3 2 negative plus 8H plus giving 2Cr3 plus 3SO4 2 negative plus 4 times H2O. So this is your final redox balanced reaction. And it is a self-verification method wherein you can just observe the balancing would be in terms of atoms and charges. So this is the redox reaction which is balanced in terms of atoms. Atoms are balanced on both the sides, but it's not only about the atoms. For ionic reaction, you need to also see the charges. So the balancing should always be in terms of atoms and charges, which we have already done. This is how the redox would be balanced by oxidation number method, and the medium is acidic. If similar method is to be used for basic medium, only the step number 4 would differ, where instead of adding the 8H plus, we would be adding 8OH minus on the opposite side. Meaning instead of the acidic H plus, we would add the basic H plus. Rest all the steps remain the same. Let's understand with an example. So problem 7.9. It says permanganate ion reacts with bromide ion in basic medium to give manganese dioxide and bromate ion. So I will first convert the data in words into an ionic reaction. So I have permanganate MnO4 minus reacting with bromide ion, which is Br minus, giving manganese dioxide MnO2, and bromate ion is BrO3 negative. Bromate is similar to the chlorate ion, which is ClO3 minus, which is related to the chloric acid. So that's how you can relate the bromate ion formula. Also, the medium of the reaction given is basic. So as I said, the step 1 is to write the ionic reaction, which we have written. Step 2 is the ABI rule. So you have to perform 3 things for the given reaction: assigning, balancing, and identification. So I'll rewrite the equation again and assign the oxidation state. So Mn in permanganate is +7, bromide is -1, Mn is +4, and bromine is +5. Balancing is not required because Mn is single and Br is also single atom on both the sides. So assign is done. Balancing is not required here. Identification, plus 472 plus 4, it undergoes reduction, and minus 1 2 plus 5, it undergoes oxidation. So step 2, ABI step is done. Step 3, you find the increase, decrease, and then balance it with respect to the LCM step. So once again, the increase is happening in the oxidation number of bromine, which is from minus 1 to plus 5, which will be equal to plus 6 ka increase, again per atom, but still the number of atoms is 1. So total increase utna hi rahega. Specifically, we write so that we don't mess up with the number of atoms if they are more than 1. So ये plus 6 आया. Similarly, the decrease in oxidation number is happening for manganese from plus 7 to plus 4, which is equal to minus 3 again per atom. Therefore, the total increase would be equal to, total decrease would be minus 3 times 1 equal to minus 3. Now, as I say, the step 3 is the LCM step. So 3 and 6 का LCM 6 हो जाएगा. तो 3 वाले को 2 से मल्टीप्लाई करना है. Conclusion, multiply Mn species by 2 on both sides. On both sides. Therefore, we'll have MnO4 minus twice plus Br minus, giving twice MnO2 and BrO3 minus. That's the step number 3. Now the step number 4 is balancing charges. Charge balancing step. Step 4 is charge balancing step. So let's see the charges. There's minus 2 and minus 1. That's minus 3 on the left, and 0 and minus 1. That is minus 1 on the right. So this minus 3 will be balanced with minus 1 by adding the OH minus, as the medium is basic. So the OH will be added on the right so that this minus 3 becomes equal to minus 3 on the right. So finally, step 4 is MnO4 minus 2 moles with Br minus, giving 2 MnO2 plus BrO3 minus and 2 OH minus. And step 5 is the oxygen balancing step, where you count the oxygen on both the sides. So 2 4s are 8, 8 oxygen on the left, 2 2s are 4, plus 3 7, and plus 2, that is 9. So 8 and 9 would be balanced by plus 1 on the left, which means you have to add 1 H2O on the left-hand side, thereby giving the reaction 2MnO4 minus plus Br minus plus water, giving 2MnO2 plus BrO3 minus and 2 OH minus. That is the balanced redox reaction by oxidation number method, and the medium of the reaction is basic. Again, this redox reaction is balanced in terms of atoms as well as charges. Fine. Now, as I said, there are two methods which we are going to focus. The first is oxidation number method, with the variation of acidic and basic medium both covered. And now we move to the second part, that is the half reaction method. The half reaction is also called as ion electron method. Half reaction is also called ion electron method. So again, the half reaction method, from the name you can understand, here we are going to break down the reaction into two halves, and we'll balance the half reaction individually and then finally come at the full reaction. So I'll take the example, problem 7.10. Again, the statement, permanganate ion in basic medium, oxidize iodide to produce molecular iodine, and manganese oxide with oxidation number 4. Write a balanced ionic equation to represent this redox reaction. So step 1 and 2 in the half reaction method again remains the same. जो हमने oxidation number method में पढ़ा था, the step number 1 and 2 remains the same. So convert the data in words into a reaction, which is permanganate MnO4 minus oxidizing iodide I negative to give manganese dioxide with plus 4 and molecular iodine, that is I2. Step 2 was the ABI, assign balance identify. So we'll perform that by calculating the oxidation number. MnO4 minus plus I minus giving MnO2 plus I2. The signing gives Mn plus 7, iodine is minus 1, Mn will be plus 4, I2 is bachelor 0. Balancing for Mn not required, but iodine is required, so I'll introduce 2. And assigning would be, identification would be 7 to 4 is reduction and minus 1 to 0 is oxidation. Now, from the step number 3, the half reaction method has different approach. So we have to break down this reaction into two halves. One would be called oxidation half reaction and other would be called reduction half reaction. The oxidation half will be the part undergoing oxidation, which is 2I negative giving I2, and reduction half would be MnO4 minus giving MnO2. Now, to balance any half reaction, I'll give you the set of 4 rules which is to be followed for balancing any half reaction. So कोई भी half reaction balance करना है. Step 1, balance the oxygen. The oxygen needs to be balanced via water, H2O. Step number 2, balance hydrogen. Hydrogen needs to be balanced via H+. Now step 2 will be done when the medium is acidic or basic. But in the case of basic medium, you have to do the third step as well, meaning when the medium is basic, you have to add OH minus equal to H plus. Add OH minus equal to H plus on both the sides. Concept ये है कि acidic medium में will have H plus, basic medium में we need to neutralize the H plus and make the OH minus appear. That is why on both the sides we'll add the OH minus. On one side it will neutralize, on other side it will make the OH appear. And lastly, the balancing of charges. We have to balance the charges, and here it is via the electron transfer. That is the loss and gain. So just follow the 4 steps as we have discussed here, and you will get any half reaction ka balance. So let's understand with the example here. There is 2I minus giving I2. Balance oxygen. Now, first step is not required because there are no oxygens on either sides. So even the second step will not be required. And here, whether medium is acidic or basic, the third step is also not required because hydrogen ही नहीं exist करता है. Basically, for the OHR, only the fourth step is required. The fourth step में क्या बोला है? Balance the charges. So I have a minus 2 on the left hand side and I have a 0 on the right. Now electrons are negatively charged, so I will introduce a minus 2 on the right side to equate the minus 2 on the left. So this will be done by adding 2 electrons on the right. And this has to be the case because oxidation is loss of electron. So the electrons need to appear on the right. Now let's apply all the 4 steps for the RHR. First step, oxygen. Now here 4 oxygen and on the right 2 oxygen. So oxygen ka kami hai on the right. So I will add 2H2O on the right. Balancing oxygen via H2O. Then hydrogen, nothing on the left, but 4 on the right. So I need to balance the hydrogen by adding 4H plus to the left. Then third step is simply whatever number of H plus, you add OH minus equal to that on both the sides. So I'm adding 4OH minus on both the sides. Having done that, as I said, these OH minus will be neutralizing the 4H plus, effectively giving you 4H2O. So I'm just rewriting this equation. MnO4 minus with 4H2O is giving MnO2 plus 4OH minus and twice H2O. But if there are similar terms on both the sides, maths mein, if I have x plus 4y equal to z plus 2y, हम y को यहाँ पर लेकर आते हैं और x plus 2y equal to z करते हैं, तो सेम चीज यहाँ पर भी अप्लाई करना है. This 2H2O I can subtract with the 4 1. So finally, this 2H2O will go away and this 4H2O will change to twice. So till here, what we have done is followed the 3 steps and balanced all the atoms. If you observe, Mn, hydrogen and oxygen are balanced. Lastly, the charge. The charge on the left hand side is -1 and charge on the right hand side is -4. So negative charge will be added of -3 on the left hand side to balance the -4. So effectively, I have to add 3 electrons on the left. So this is the half reaction, oxidation, and this is the half reaction, reduction. So we have balanced the 2 half by applying the 4-step method. Now दोनों को ऐड करेंगे, they will get the net reaction. तो उसके लिए सबसे पहले, if you observe, the loss of electron is 2 and the gain is 3. The concept of balancing is the number of electrons lost should be equal to the number of electrons gained. So what we are going to do is we will take the LCM 2 and 3 ka 6 and multiply this by 3 and this reaction by 2 so that the 6 electrons now lost would be equal to 6 electrons gained. And this is your main conceptual fundamental method. Now just multiply 3 inside and take the LHS down. Multiply 3 inside, 2 inside and take the RHS down. So with 3 into 2, I will have 6 I negative plus 2 MnO4 minus plus 4H2O. And that would give 3 under multiply karenge. So 3I2 plus ye 2 inside, 2 MnO2 and HOH minus. This is your final balanced reaction. So out of the 2 methods, if I say which one is better, if you are not told the method, then obviously the first method, oxidation number method, is a simple method as compared to the half reaction method. But this method would be very important if you are just given the half reaction to balance. Because for half reaction, कितना इलेक्ट्रॉन का लॉस या गेन होगा, आपको सिर्फ यही मेथड बता सकता है, which is ion electron or the half reaction method. Now, apart from this regular examples, I will discuss one good example of disproportionation. Now, disproportionation में भी सब steps similar है, but one or two things is to be understood with caution. Let's take an example. I have P4 reacting with OH negative, giving PH3 and H2PO2 minus. So here we know that this is a famous reaction of disproportionation because phosphorus in the zero changes to -3 as well as +1, meaning it is undergoing reduction as well as oxidation. So when you have the arrows shooted from the same element, it is a disproportionation reaction ka case. Okay. Now to balance this, the step one is similar. Step one meaning the ionic reaction is already given. Step two would be ABI. Step two may in the ABI part assign but don't balance the atoms and identify. Here the balancing of the phosphorus is not to be done. So I've already assigned the oxidation number. I have identified the oxidation and reduction, but I've not touched the balancing of the phosphorus. So step number 2 में ABI का B नहीं करना है. अब step number 3 में we have to identify the increase. So the same element phosphorus which is undergoing the increase as well as decrease. Increase हो रहा है from 0 to +1 which is +1 per atom. A number of atoms here is to be taken for this phosphorus. So H2PO2 minus में एक ही phosphorus है, so into 1 is +1. And decrease हो रहा है from 0 to -3, which is -3. Again the number of atom सिर्फ ये वाला लेना है, तो into 1, that's -3. अब LCM ले लो, because step 3 को तो हमने LCM step ही बोला था. तो LCM step के हिसाब से here the 1 वाला species will be multiplied by 3. But now caution ये है कि this multiplication is to be done on the right hand side only. Meaning the 1 wala species which is H2PO2 minus will be multiplied by 3 on the RHS. And now count the phosphorus atoms on the right and balance the left hand side phosphorus LHS P atom. Okay, so here the total phosphorus atom is P and 3P, which is 4, and 4 phosphorus is now already balanced. So this will be only 1 mole. ऐसा हमेशा नहीं है कि 1 मोल होना चाहिए. यहाँ पर अगर मान लो 8 phosphorus atom आते तो it would have been 2P4. So whatever number of phosphorus on the right, balance the left hand side phosphorus accordingly. So these two things are different whenever we have a disproportionation reaction in consideration. बाकी सारे steps remain the same. So बाकी steps में step number 4 was of the balancing charges. So the charge on the left hand side you observe is -1. The charge on the right is -3. And the charge balancing is done by adding 2 OH minus on the left hand side, which will equate this equation. So with OH minus already present, if I add 2 OH minus, effectively 3 OH minus हो जाएगा. So now the charge is balanced. Fifth step में oxygen atoms देखते हैं. So there are 3 oxygen on the left hand side, P4 plus 3 OH minus, and right में 3 into 2, that is 6 oxygen. 3 और 6 को balance करने के लिए I'll add 3H2O on the left hand side, and this is my balanced disproportionation redox reaction. So the same oxidation number method is used to balance this disproportionation reaction, just that the balancing part is little bit twisted, otherwise everything else remains the same. Now one more case of peroxide needs to be understood properly. So let's say I have H2O2 reacting with Fe2 plus and giving Fe3 plus and H2. The medium of the reaction mentioned acidic. So now we have to just use all the steps in the similar manner and balance it by the oxidation number method or the ion electron method. And as I said, the favorable will be the oxidation number method. अब यहाँ पर भी you have to solve this particular example with caution because it includes the hydrogen peroxide. What's so special about this? Peroxide में oxygen has the oxidation number of -1. And if you observe, the oxygen in the water is -2. So here there is oxygen atom undergoing the change. So स्टेप 1 के बाद जब मैं स्टेप 2 बोलता था ABI, उसमें हम बोलते थे असाइन द ऑक्सीडेशन नंबर, जो मैं यहाँ पर -1 ऑक्सीजन का, फेरस फेरिक ऑलरेडी असाइंड है, और -2 वाटर के ऑक्सीजन का. तो A इज डन. B में as we say balance all the atom except hydrogen oxygen, वो यहाँ पर थोड़ा सा ट्विस्ट करना है क्योंकि here the oxygen is also undergoing the change. तो आपको यहाँ पर ऑक्सीजन बैलेंस करना पड़ेगा. So 2 oxygen on the left will be balanced with 2 oxygen on the right. तो ये एक चीज आपको कॉशियसली करना है, बाकी सब कुछ सेम है. आइडेंटिफिकेशन -1 से लेकर -2 is reduction and +2 से लेकर +3 is oxidation. So step 2 is done. Step number 3 में we identify the increase. तो increase हो रहा है ion का, +2 से +3 that is +1 into number of atom 1 यानी +1 का increase. Oxygen में peroxide is changing from -1 to -2, that's -1, into the number of atoms is 2 and that's why -2. अब अगेन LCM स्टेप में है, 1 and 2 का LCM 2 है, so इसको 2 से मल्टीप्लाई करो, मतलब multiply the ion species by 2 on both the sides. That completes your step 3. Then step number 4 is a charge balance. The charge on the left hand side, if you observe, this is 0. H2O2 पूरा न्यूट्रल कंपाउंड है, -1 उसका ऑक्सीडेशन नंबर है, चार्ज नहीं है. ठीक है, so 2 into 2 is +4 on the left, 2 into 3 plus, that is 6, +6 on the right. तो 4 और 6 को बैलेंस करेंगे, मीडियम एसिडिक है, by adding 2H plus on the left hand side. So here I add 2H plus. Step number 4 done. फिर स्टेप नंबर 5 में ऑक्सीजन बैलेंसिंग आ जाएगा. तो ऑक्सीजन एटम्स कितने हैं? 2, नथिंग नथिंग, मतलब 2 ऑक्सीजन and here 2 oxygen. Here if you see both the sides the oxygen is same, मतलब step number 5 is not applicable. मतलब what we have as final reaction is the redox balance reaction. So this is about the balancing part having 3 variation. First, I would call it as general variation. Second is the disproportionation wala, solve with caution. And third is the peroxide wala example, solve it with caution. Rest, if you just follow the steps, whether by oxidation number method or the ion electron method, you will get your answer correct. Thank you.